Well, after moving back to Zoom, I guess I cannot create those scripts, polls so easily. But you can probably still type in the chat window if you want to say something. You know, it is very good, very important for us to have communication of almost any kind. Without communication, then it is very difficult to know what people want. And it is very difficult to create computer programs that does what people want. And knowing what people want is very important for anything. No? Yeah? I'd love to know your comments. So schedule today. Oh, for those who just joined, I need you to do me a favor, to type in the chat, telling me that, could you see the message that I sent before you joined at 6:54? No. Okay. Thanks, HC. Thanks, brother. And I wonder, do you often do, well, I think you often do this online lecture recently. So did you happen to do online meetings also? Are you used to online meetings, and do you think you know how to do this online meeting with effective and efficient arrangement? Or let me put it another way. Do you know how to be efficient to do meetings online? It's probably still a question that's too complicated. Okay, yet another way to express it is that, do you know how to collaborate online efficiently? Okay, so you said create a meeting note. Oh yeah, that's a very useful technique of running a meeting efficiently. Yeah, but that is, I think, general to all meetings, that you should have someone to prepare the notes when you are in the meeting, so that everybody knows, everybody will remember what is being talked about. Yeah, that's a good thing. But there are more. So since we are doing online lecturing, I am also thinking how to help us to have a little bit of experiences about to efficiently do a meeting online. But that's kind of hard because to practice or to learn how to do online meeting efficiently, first you need to have a goal that need more people, more than one people, to work on something. But that is not the setting of this course, right? because I do not want you to collaborate on have you had good experience in collaborative projects, be it a side project or a school project? And anyway, did you have good experience to work with people for a project before today? If you do, please say something or type in the chat. Oh, that's good. I see two people, HC and Crystal, and I heard somebody probably trying to say something about maybe about the good experience of collaboration. Would you mind to share some of your experience to the class? What was that scenario? How many people you work together? Yeah. So I am assuming that you probably can turn on the microphone, but if you cannot turn on the microphone, that's okay. We can maybe save it for another time. Okay, so anyone among us, including like HC or Crystal, do you want to say something? HC has a roommate sleeping. Yeah, better not to wake them up too early, right? Yeah, I know that a lot of us are not in a surrounding that is very okay to speak loudly. Yeah, that is fine. Oh, Crystal post in the chat saying there are two people or use online meeting to do the discussions. Okay, that is good. In my personal experience, so it's like 20 more years since I started in university or something, that collaboration is difficult, no matter you are in person or online. And online discussions or collaboration is even more difficult because usually you do not see and feel people that you are collaborating with. That creates a lot of misunderstandings. And misunderstandings is what we call frictions during collaboration. And it is also provide us less information or clues about, okay, on this matter, how do we divide those work? And how do we send work to different people who are probably most suitable for the subtask? And during that determination, you need to have iterations. You try and error. That's basically all scientists and engineers do, right? You make a guess, you try based on your guess, or some would say faith. Then you figure out, oh yeah, part of the guess was right, but maybe more portion in the guess was wrong. So we reiterate and try to fix the errors and move things forward. But that iteration loop become very long when people are not sitting in the same room or sitting in the same office. So, and I then realized that probably was why most of the projects in university didn't collaborate so well, because everybody is free to go anywhere. They say you form a team of the number of 3, And you need to schedule some common hours for you to sit together or work together. And you all have different personalities. You have different social circles. So you probably won't have sufficient time to get together. Then the collaboration becomes difficult. Right now we have online tools, so we probably can go online, but let actually keep more distance between people. But when you are in a real office, and that's why office is so important, that people are actually be together. And when in my first job, I worked in Zhongshan 科学研究院, the Zhongshan Institute of Science and Technology. That's the place that we made missile in Taiwan. So I was trained as a mechanical engineer. Yeah, all my trainings are for mechanical engineering, actually. So at that time, I thought that I want to make, I didn't really want to make missiles or weapons, not even now, but I wanted to make something that computes. I want to see the physics compute in computers. And I did fluid dynamics. So I thought I want to go to a place that there are a lot of computers and there are real things that requires the computations for fluid dynamics. And that was CSIST. And, that's a defense institute, so it is highly classified. So they have a very, very interesting floor plan for offices that almost everyone is in a standalone office. Some of us, like me as a very young junior new hire, I share an office with a colleague. So two of us in one office. But we shared a room of probably like how large it is? 4 to 6 pin. So that's probably 15 square meters. So that's quite large, right? That's quite a spacious office. And let me cut into chase. In each afternoon, every afternoon, there's a colleague of another colleague just fooling around the whole office building. We have like 30 people in the building. And he visited each of the offices and chat with us. He spent the full afternoon chatting with people every day. Then you will think, okay, then that's probably why our government or military institute wasn't so efficient. That's a valid guess, but wrong. He is the most productive person in the whole department. He is very good. He told me, because he educated me a lot of things. There's a senior engineer that I admire a lot. So he actually can program for like 24 hours or maybe even more than 24 hours when he was young, or when I met him. It's outstanding. But he said he needed to talk to everybody so that he understand what the real requirements is. And I keep his words in mind until now, and I think it is so true. So I speak it to you. So that's the story. Speak to people and listen to people, even though you need to spend the whole afternoon talking to everybody of the 30 colleagues in your department. That was it. That will make you the most productive guy or lady in your surrounding. Okay. Of course, you need to be a nice person, right? Everybody loves to talk to me. And Crystal have a second comment said that after every meeting, we'll do the note to sync the info. That's a very, very good point too. Yeah. So you see, that's you can walk around to talk to people, and you memorize that in mind. Well, that's good. Or you have a formal and you have a formal setting, let's say you sit down and review the note and think the understandings, right? That in the tech sector, we usually call, I think maybe in all business sectors, we say this is what we call alignment, okay? We align to each other. So I align with Hao Yuan, I align with like Zhizhen, and I say something and I confirm with, say, Sam, hey, what's your understanding of what I said? And Sam will say something. And don't be shy at this point. Just say something. And I say, oh, that's not what I meant. So sorry that I probably didn't make myself very clear. So let me do that again. And we continue until that we align to our information or opinion, or sometimes that we align to a point that we know we do not align. Maybe our things, our thoughts, or what we know are just divergent, and we recognize that, and maybe in the future we'll come back and fix that divergence. Maybe one of us is wrong, or maybe both of us was wrong. It doesn't matter. What matters is that when we work as a team, we try to align together by all the means that we have. Then we can create an environment that we do better than we work alone, and we do more than we work alone. Okay. You can interrupt me anytime. That later, if you think of anything related or maybe unrelated, and we can talk again. And today, the lecture, I'm going to cover basic C++ and computer architecture that is behind C++. So the reason for using C++ or any low-level programming language is just for the speed. Okay, speed is the king. If you run 10 times faster than everybody else, then no matter how bad your code is, you win. All right. If you run 100 faster than other people, then you are an unquestionable winner. Okay. So, but of course, you need to deliver on time. So C++ is not the whole story. Why? So we want to use C++. Why C++? Because we want it fast, and we enjoy a very good support from the community, or we say the industry, because there are a lot of people making very good compilers for C++. Okay. There are many very good programming languages, but they have not been around for as long as C++. So there has not been sufficient resources invested in making those compilers so good as C++. And for the same reason, because C++ has been there for so long time, then when you want to improve the technology, you have tons of resources for you to dispense. And that is, well, that may not be the best thing for original research. If you want to do original research, there are so many prior arts and there's no land left for you to stand on. No new lands for you to explore, right? So that's not the greatest thing. But if you do not care about expanding the boundaries of human understandings to the universe, all you want to do is to make money easily. Well, I sound corrupted, right? I know. it doesn't really matter whether or not I'm doing the new things. What matters is that I honestly work out on the most dependable technology that I know and make it fast. Yeah, so C++ is very good at that. And if we are not satisfied by whatever the language or the compiler provides us, we can just write assembly, which is kind of encouraged by C++ or C. It allows you to do that and does not put some safety belt on you when you want to go assembly, right? A lot of more advanced languages, they say, hey, something is too dangerous. I will make it your life hard when you want to use that useful but dangerous features. But C++ is not saying that. He just gives you a rocky engine, and that's it. That's what you got. You can do whatever you want. And we mentioned C++ has been there for a long time. So people would say it's so old, a lot of legacy, so it's not easy to maintain. That's true as well. But that is mostly talking about that how you maintain the legacy code, how you save your resources in maintaining the old code. That is not about how you are going to hire people or spend a lot of money to get somebody who's really good at C++, who maybe even is part of the C++ standard committee. So he knows the language well, right? Yeah, you can hire a lot of people like that. And that's good for maintenance, right? So that's another perspective. When you do have the money, can your money buy maintenance? Yes, you can for C++. And that is particularly true for numerical codes because our codes, well, we tend to say a numerical program as a numerical code. So it's uncountable now. The line of code is uncountable, right? But each of the code may live for like 10, 20, or 30 years. People still use it because, well, it's not so difficult to start from scratch. But when you are thinking about the existing results that it generates, you will still need to run it, right? The results that those mathematical or scientific things that created is not so easy to understand. It's not the code. Code is difficult to understand as well, but it's the result that difficult to understand. So you better have a tool, a code that can be used to regenerate it on and on, so that can study it. So that's one thing. Another thing is that you need to go with a lot of third-party dependencies. And then that things, even if you want, it may not go with another language, or may stay with C++, or stay with a foreign interface that compatible with C++. So you still need a way to use it. Right? A quick question. This is an interview question I love to ask. Yeah. So how about you type your answers in the chat? I'll give you like 30 seconds, or maybe a minute. Yeah, so 08 said something. Well, answer into your conscience, okay? Don't look at the chat and try to copy the answer. That doesn't mean anything to you. Ask yourself, what smart pointers have you used? And if you used any of them, for what reason? All right. You look at the schedule, you'll notice that later, I think the second half of the semester, we will talk about smart pointers. Yeah. Chris said that you hasn't used before. Yeah. You're honest. You're starting to be honest to yourself, and you start to learn. But you do not need, if you do not know and you do not want to answer, that's perfectly fine. You are also very honest to yourself, but answer to yourself. If you don't want to put that in public, answer to yourself and ask you, why does that matter? What should I learn? Okay. Because it takes a long time for you to learn C++. That is very, that is not good news, right? I learned, I started my program by learning C, I think. Yeah, C, when I was still in high school. So I was just trying to play something. So that's take something to learn. Then I think my formal education of learning the programming language was for Fortran, because, well, Fortran has been unpopular for a very long time. So only in the engineering school they teach Fortran. So I learned Fortran, but I don't think they teach Fortran anymore. What a pity. It's a good language. Then everything else that for programming I learned was by myself. So I learned C++ myself. But at the beginning, that I thought I know C++. I knew C++ because I've written a couple of programs and runs pretty well. And I know how to use classes and inheritance, all that, those kind of cool stuff of object-oriented programming. So I was supposed to be pretty good. Then I realized that I was totally wrong. That wow, there's a lot of things in C++, so I can not cover all of them in today's lecture. Even I don't really think I can run through all my slides today, but that's okay. I will start with how to build a program. This is very basic things. So most of things that I'm going to cover is basic today, but they are the starting points for you to self-study and to write programs. And you do not need to write perfect Python or C++ in this class. You do not need to. You give yourself some room to appreciate the process of learning something you don't know, and learn and practice something that you are already good at, and to sharpen it, to further improve your skill. Okay, because I want you to have this experience, because that's what we do every day in my work environment. One thing I want to say about what we do is how we work is that the team that I'm in is kind of in the leading edge of the semiconductor manufacturing. So we learn many things from our advanced customers. They asked us to work with them to solve the problems that they do not know, and not to say how to solve them. So the feeling of that is like, wow, there are so many problems that nobody ever want to write a paper for. So when we are working on the problems, it's basically like repeating my PhD training on and on and on. You know, if you want to go for a graduate school, for PhD study, you need to know that you are trying to find some problems that nobody has solved before. Okay, you are not trying to solve the problem. Right now, we are trying to solve problems in the course, in the maybe in the master program, or if you are lucky that in your undergrad program, you try to solve some problems. But people will tell you what is the problem most of the time, right? But the PhD training is, I don't know if there are any PhD students here, but if you are that, but anyway, it is about to find problems. And we are finding problems every day in our daily work. So unlike most of the software development, that they can specify the problems and to solve the problem, right? So there probably is a project manager trying to specify the project for the programmers. That won't happen with us, because we developers, we are also researchers. we need to find the problems. If you do not know the problems, how are you going to solve it, right? So that's exciting, no? So then we go back to the basics, because there is not a well-organized way to frame the problems. What we have is the basics. So when we build systems that, if we have higher level constructs to use, that we use it, and that's more productive. But if not, we may go back to simple things like how to compile and link. Okay, well, how to compile and link in our context. Okay, just like how to compile and link in our programming context. So we know that to build, we say a compile language that requires a compiler. You need a compiler here to turn a source file into an object file. Okay, in this arrow, a source file to object file. So the work is that there are plain text. Okay, sometimes there are more contents than plain text, but most of the time it's plain text, the source code, right? That's a lot of lines. Then transform to the target assembly or machine, actually a machine code. Some compilers will have more phases. Well, I should say that C++ compilers tend to have a lot of phases in between. So this error is a super simplification of how the thing works. Okay, so that's the first part. The second part is that the object file or object files, there may and usually are a lot of object files here. And the linker, link to executable. And you already noticed that the compiler and linker is actually the same command, right? So this G++ or C++ binary file, or maybe sometimes it's a script, actually will call other programs. So in this linking phase, it will call the linker and to get the object file and produce the executable. Okay. And object file are assembly code or are machine code, but they do not run. So you compile. This -c is almost universal to all compilers. So when you see a -c, then we are compiling something to object file, to machine code. But that is saying that machine code alone doesn't run. It is just the code that computers can understand, but it does not know computers know how to run it. It's like that you have a pair of running shoes that those shoes allow you to run, or allow you to run without being hurt, right? But if there is not a road, you can run for like 3 steps, then you got stuck, right? Probably there's a tree, well, maybe 10, a forest in front of you, and you do not know how to enter. That is like the compiled object file. Yeah, the things, the code inside the file are runnable, but the file itself is not in the format that is executable. So let's try it. Let's open up. Let's turn on the execution bed for that object file. So we are supposed to be able to run it. So you see that the shell is trying to run it, trying to load it into the memory, and it doesn't work. Okay. In Linux, that you will see some other messages. So we need to link to the executable. Okay. We get this executable file. This utility actually show you the information. It will read the content and try to guess the format of this file. Then we can run it. And this compiler front end can compile and link in the same time. And that's actually what we usually do when we have only one or maybe three or maybe four source files that we want to compile and build. Okay. Okay. So we mentioned that usually we have more object files, right? That is that when we have a complicated program, when we usually do, right? Like for your term projects, you are supposed to handle some complicated problems. So you should modularize or separate the code of your program. So this is the most common separation. We have a main program on the left-hand side, and we have the worker code on the right-hand side. The worker code is to print hello. And the main program does not care what is the real things to be done, but it provides the what we call the entry point of this executable. It's the main function decided by the C++ standard. I do have an interesting question for you. If you want to answer, you can type or just stop me. How do you think, is there any program executed before this main function? Yes or no? And you can also say, if yes, if you can say what is executed before entering this function. When I say being executed, is the code you write in your program. Okay, it's not the other program. It's not the operating system. It's the code written in your program. Is anything else executed before main function? C runtime, of course, C runtime runs, but C runtime is not in your program, right? The code you didn't write the code. Is there any code you wrote in your program being executed before main function? Macro is not code. Macro is the pre-processing. So it is executed by the preprocessor. It's even executed before compiler. And hello, HPP. Yes and no. Yeah, the code is definitely being understood before the point of, so it's close to the answer. But you see, it doesn't execute, right? The header file here is being included into two source files. So Asma, I need to thank you that you actually bring us back to the subject. These things are consumed by these two files, but it is only the declaration. So that in our worker code, in our main program, we know there is a function called hello, and it takes no argument and returns nothing. And that's it. So that the main program knows how to find that hello and run it, put it on the stack and take it back. All right. Okay, I will leave the answers for you to Google for study. And whenever you have some thoughts, we can discuss. Okay. Then we have these two source files. We compile them right here. Get the hello-man.o and get hello.o. Then we link these two object file into an executable. Sweet. Okay, and sometimes we want to make libraries. When we are making a hybrid system of C++ and Python, we always make libraries, okay, and the share library on the right-hand side. But the basic thing is a static library. We build the object file, it's already linkable, right? Then we put this object file into a library file or archive file. I think the archive file probably was a legacy name, but people are still talking about it as using this term. But this is static library. So when you are linking your program, linking into executable, then you tell the linker or simulate the compiler. So sometimes we use the term interchangeably. Okay. we specify where is the library file. By default, there is a search path for all the libraries by the linker. But if it is not in the place that it usually be, then you need to tell it. So in this case, we have the library file in our current directory, so use dot. Then tell the linker what is the library we want to link. Okay, the capital L is where to find all the libraries. The lowercase l is what is my library. Okay, and you see that in this interface, there are other interfaces for linking, but in this interface, you do not specify the extension file name. Then there's another way to create library. That's what we call dynamic library. So a static library is called static because it needs to be linked. It needs to be linked during construction of the binary file. This hello man2 binary file. You cannot after you create the binary file, you cannot link in static library. That's why they call static. You have to get it when you are making the executable. But shared library is not like that. Okay. Shared library, well, you still need to have library file when you are making the executable. Okay. But let me go here. The syntax for linking shared library or dynamic library is the same as static library. But the shared library needs to be built differently. So here, first thing is that we usually need, sometimes we do not, but usually we need to make sure when we build the object file, the assembly we created is what we call position independent code. The reason is that when we are loading the shared library into memory, it is not happened during our thinking, or let's say making the executable. It has happened when the main program is being loaded into memory. Then the linker, dynamic linker, will notice in our hello man3 has a library that is needed to be dynamically linked. So it will go into the dynamic linking search path to see if it has that shared library and link it during runtime when we launch the main program. So it is different from the static library. Static library, the code is already built in the executable. So when you are loading the executable, you are loading the library file. It's part of the executable. You load it all together. However, the shared library will be linked during compile time. So during this linking phase, it does not really link the code into the executable. It linking the symbol into the executable. It only says, okay, in hello man3, there will be some functions, some symbol, we call symbol, because sometimes they are not functions. There will be something that the dynamic loader needs to load during runtime. So that's it. So let's see the file size of the two resulting executable. For the static linked hello man2, the static linked one, you see the file size is like 56K. But for hello man3, which is dynamic link, you see it's slightly smaller, right? So there is not a big difference because we have so little code in both files. So most of the assembly code in the executable are for housekeeping. There are a lot of code that we didn't write, but they are built in the binary. But the code we write has like a 6 kilobyte of difference. Okay, and that is why we want to use dynamic linking library. Okay, sometimes dynamic library runs slower than static library. Okay, static library usually can run faster than shared library. We still usually go with shared library, but in some computers, especially those small computers like MCU, they may or may not use shared library. But at that time, that the claim that we always use shared library falls apart, because there are a lot of resource constraints on small computers. So sometimes you cannot go with shared library, but sometimes you need to go to shared library because of the constraint. I'm not an expert of the small computers, because for numerical calculation, we need to use big computers. So whenever we can, we use shared library. Okay? But you need to know there's a difference between them. Okay. As I will go I will go continuously of the lecture, but I really want that you have questions and you have, you need to ask, you need to practice, that you know how to ask. Okay, so I so want you to be able to ask. If you can ask in voice, that will be perfect. Okay, but if not, you type in the chat and we can still do some discussions. And what matters is that you ask questions and we discuss. So you use English, you use Mandarin, are all okay. All right. But of course, I want you to have the experience of English discussions. So I will try to make sure that you experience that. So we well, in the previous page, we built our own libraries, but actually, usually we will use libraries other people built for us. So this is an example that we will use BLAS for some computation. So we include the BLAS header file. Inclusion of the header file is not using the library. It's just part of the work of using a library. What it does is to tell compiler, hey, go to find this header file. It contains the declaration, the signature of symbols that I want to use. For signature is usually for functions, but there can be other symbols like global variables. Yeah. People are saying that global variables are bad. Yeah, they are bad, but they are everywhere. So get used to it. You have to use global variables. So this is the file that, this is one of the functions that BLAS provide. So it calculates the dot product of two vectors. So okay, compilation is okay. Oh no, sorry. Here I am combining compilation with linking together. So when linking, this error message pop up when linking, not compiling. Compiling has passed. But when it wants to link into the executable, it complains that it does not find the symbol here, which is not part of my source code. It's somewhere else. And you see, linker does not know which library it needs to provide. The header file does not provide information about the library. That's an intentional design. Okay, header files and library file are two different things. So the linker does not know where to find this. We need to tell it that in my search path, there is a library called CBLAS. Find it. And linker will go search everything in all the libraries and object code it knows, and to combine, to insert the symbol into the distance executable. That means if you tell the linker maybe two libraries, one is say C+ and say C+2. Suppose you have these two libraries and contains both contains this C plus underscore D dot. Then linker will have a problem. The default setting will force the linker to fail, to stop, saying it finds duplicate symbols and does not know how to deal with duplicate symbols. Okay, so that's the default behavior, but you can override. So to make the linker to link both of the symbols into your destination. So I don't know whether or not you run into this kind of scenarios, but it happens. It's a feature, not a bug. So be aware of things. That is linking. Then let's talk about C++ per se. Now we know how to compile and link, right? I was in the conference yesterday, so I forgot to send out the homework number 2. I will do it later after class. So you can start to write some C++. This is an integer type that C++ supports. It supports a little bit more, but mostly we will use this up to the 64 bits. Right now, we do not have a popular machine that support more than 64 bits on a regular basis. There are machines that can support this, but not popular. The Boolean is not exactly integer type, but I still categorize it. So be careful about this definition if you didn't notice before. In C++, when you are using this type name, bool, short, integer, long, they are not all fixed widths. Okay, the width is that the size of this data type are defined to have minimum. Okay, so if you see a short, it cannot be a byte because a byte is a character. Okay, the characters are actually the only exception I know that has a fixed definition. So a byte is 8-bit, but you know, a byte is not always 8-bit. There was some time that a byte was either 6, 7, or 8 bits. It's a very early stage that people haven't decided how long a byte need to go. So byte was at that time was only a bucket for some bits. People define it as a bucket of some bits. And in one computer architecture, the number of bits a byte hold is the same. But they didn't agree on a standard about how many bits a byte wants. But right now we do have a standard. Okay, so C has a standard say how many bits a byte need to have or a character needs to have. C++ is having a compatible definition or standard for that. But you notice that bool does not have a width associated. Okay, but we know that in C and C++, the bool takes 1 bit. This is universal to all implementation that I know. But because there is not a definition or standardization, nothing prevents you from using 1 byte to store a bool. Okay, so that's tricky, right? But you see a long, can it be 64 bits? Yes, it can. It is still agreed upon the standard because the standard only say a long needs to be 4 bytes. Can it be 33 bytes? 33 bits? Well, probably, but that's silly, right? But having it 8 bytes or 64 bits, well, makes sense. It's perfect matching the standard. It just a little bit larger memory, right? Okay, so you can write simple test program to see yourself. It is very interesting. Okay, I didn't print Boolean. Why I didn't? can remember. All right, that's integer type. Again, this is also integer type, but they are fixed weights. This is what we use for numerical calculation. Because when we want to do calculation, we care a lot about the range of values that we can trust, and we need to be very careful about underflow and overflow. Let me come back. These fundamental integer types are used for cross-platform hardware platform computing, and that's very important. If you do not have a flexible definition about how integers go, then when you are porting the system to another platform, you will find it becomes very difficult for you to know what is what types to be used for certain values. Okay, so this type names are more like the placeholder for something that can vary between hardware. Okay, and designing hardware is more difficult than designing software, right? Takes more time, more efforts, more money. So the general concept is that, okay, when we can accommodate in the software parts, in the source code, we accommodate in the source code. Okay, but if we need to do like if and else, the macro if and else everywhere for the time name, it's silly, right? So let's make this with variation into the language standard. Let the language decide for us. Okay, and the language or the compiler implementation needs to provide a lot of macro, okay, to switch between those widths of size among different implementations. So different implementation usually can come with a different header file inside this compiler distribution to make the definition work on the different hardware. But we do not worry about that for numerical calculation. Okay, the previous page was the context of why we do have these two types of type names. For numerical calculation, we need to know the exact value range, and we do not care whether or not the new hardware are used in different things because we already fix it. Okay, if the new hardware does not support the weights we want to use, our program won't compile, right? Then we know that is not the hardware we are going to use. Do you know how do we solve this problem? You can try to answer this question. And if the target hardware platform does not support the value range we want to use, what are we gonna do? We don't buy it. we simply put aside it. So in the early evaluation, we will realize, oh, this fancy ARM machine is not designed for scientific computing. It's not designed for engineering use. That's just a fancy toys on smartphone. Okay, of course. Well, ARM does support this kind of value range. It's actually used in the server arena right now, so it's perfectly fine. That's just an example. Say if we see a platform that does not support this kind of thing, we get rid of it. We don't use it. Okay, so this is a tricky reminder to you that the difference between signed and unsigned integer matters. For floating points, which we will include later on, they're always signed, but integer made a difference between signedness because of the Boolean algebra. Okay. So modern compilers will warn you about this, but still be aware of this thing, because if you manage to run on some new or small hardware, this signed integer is -1, unsigned is 1. So this signed integer is supposed to be smaller than the signed integer, right? By the number. So the task we are supposed that to be fair and printing nothing. But in reality, if you really write this program and do not tell compilers to do some special check, then you will see the negative value to be greater than the positive value. Do you know why compiler? What rationale? Okay, compiler does it all the time. Do you know the rationale behind this behavior of the compiler? Anybody? Does that ring a bell? Did you recall when you are learning C? Well, this behavior is the same between C and C++. Okay, let me put it aside. You probably are thinking about how to express it, right? I know some of you know why. Okay, let me put it aside, and it's very easy to learn by yourself. And even if you do not know exactly why, it doesn't really matter that much. What we need to know is that compiler does have a lot of behaviors that was inherited from the legacy. Right now, it does not totally make sense, but in the past, yeah, it's if it doesn't do this, some program will have a hard time. So yeah, maybe. So since we do have this warning flag here, so that's fine. So just turn on this warning and turn all the warnings into error. So when you compile this program, compiler will tell you, hey, you are comparing a signed integer with an unsigned integer. Then this thing will not be right, or is highly unlikely to be right. So when it issues this warning or error, what we need to do is say to review, am I really trying to compare two integers that are unsigned and signed? Why do I need to mix the signness? Sometimes we do. Okay, if we determine that, if we do not, then we change them to be of the same type, right? Then problem solved. If we do need to do this, what we do is that we cast this unsigned into signed. Then we enjoy the risk of overflow, right? So we can only do that when we know, yeah, it's unlikely for us to go overflow. So we can turn this unsigned integer into signed integer, then everything will be well, right? So it will become a comparison between two signed integers. Then we shouldn't get a problem like this. Okay. Did you use those warning options before? I think this question is well suited for you to type in the chat. Okay, trying to recall what you have used. You don't need to go find your older source code. You're just trying to remember what you used before. I will give you comment based on your response. Okay, this -W options you've used before. Okay, W arrow, yeah, that's very good. So you 08. Hey, if you can, how about changing your name not to number? Number is very hard to pronounce here. So change to something that's easy to pronounce so that I can call your name. Okay, and many others. So there are W arrow and W all. W arrow will turn the warnings into arrow. So the program will stop at the arrow. That will make us easier to fix it. But sometimes if you are maintaining a big program, sometimes some people introduce some warning and it turns into arrow. That will help everybody to catch that problem easily, right? So in a large software project, usually we will turn on this W arrow to make everything into arrow. And W all means turn on all warnings. Okay, all warnings in the compiler's awareness. but all warnings are not every warning. Okay, WR does not include all warning, although it seems like all warning. Oh, it's not. There are some warnings that WR does not turn up. So many times that we will use W extra in combination of WR. So they will turn on more warnings than WR. But still, that is not all warning. WR and W extra do not include all warnings. There are still some warnings that is not turned up. And there are some good reasons for compilers to do it. So you need to find out what are the switches. And that's a very good reason why we need a build system. How are you going to manage all those different switches of the compiler? You need to write some program to control the switches. And that is the build system. So you need to write program to build the program. That's kind of meta program. Okay. Thank you. And interrupt me anytime you want. Okay. So the next topic is pointers and array indexing. They are actually pretty much the same thing, but the syntax is different. There is a very, very vague difference between them, but that I will not cover those tricky things. Oh, well, those tricky things, but I will cover some tricky things today. So here is the sample. I have a data buffer on stack, but it doesn't really matter where it is. And I have a pointer pointing to the beginning of this data buffer. I have another pointer offset by 50 elements of the beginning of the data buffer. Okay, so this is the where we are. The data buffer is here. Actually, this data buffer, the symbol is pointing to the beginning of this buffer, and so is the pointer, and so after fifth element, 50 element, all data is pointing to this place, and I do some initialization so that some printing will give you values. Okay, so let's print the 10th element, which actually is the 11th element of the data buffer, and also the 11th element of the pointer. So you see that the pointer is being used like an array, right? That is supported by C and C++. So no surprise, right? If you do not know this kind of thing, you should come to talk to me. Okay, I need to have a discussion with you because this is so fundamental. We need to talk if you do not know see this before. Okay, and we use the array like a pointer. Okay, so we plus 20. This means strike to 20 elements from the beginning of data and take the value, right? So data is used as a pointer, just like the pointer itself. And they got 50, 20, the right value, all right? Still, this is very fundamental, very basic. Everybody should know it. Okay. Then the offset pointer can also be used as an array. The offset pointer is a pointer, right? As of course, it can be used as a pointer, but it can also be used as an array. So let's say first we put in the 51st element of the array. Then we print the first element of the offset data. And you see they are the same. Of course they are the same because they are pointing to the same element. Okay. And all the computation is done during compile time because we are inserting constant into the bracket or in the pointer operation. Compiler knows it. So compiler will do the calculation during compile time and build some assembly that has those constants already built in. So after that, we realize that we can actually use negative index. Yeah. Have you used negative index before? If you do, and you want to say, tell me, okay? This is also very important. But not a lot of people use a negative index before because it looks like eccentric, right? Or why am I going to index past my beginning? That's strange, right? But we can do that. So the -10 index of O data, the offset data pointer, is the 51st element. Okay, so this is -10th. This is the 51st. So let's start to have a discrepancy because we are 0 index, right? We also can use the pointer style, but they are pretty much the same thing. So some people prefer this, but I think scientists usually prefer this because this more look more like arrays or matrices. And okay, this is a question I really want to know your answer, which is that what may happen if you run this? First, you probably want to ask yourself, is it legal? Can we do that? And if we do that, what will happen? Okay. So because we are in a lecture, so I'm asking you questions like this in words. But as a programmer, when we see this, or when we thought about it, the first reaction we have is to go to the computer and type and run it. That's the fastest way to learn programming. And one of the fast ways to learn about computing and computers. So computer itself is. Yeah. Are you trying to speak? Yeah. I can hear some voices, but not the words. Maybe you are still adjusting your microphone. Okay, Igor, go ahead when you want to say something. But I have not heard any words from you. All right, and don't be afraid or don't feel embarrassed if your microphone makes some noises. It's okay. I can turn you off anytime.
It's 8:08.
So,
to hear your notifications, follow the notification on your phone to turn on notification app.
Okay, Ego does have some some more noises. So let me. I have muted him for a while. And Asne, say it will say that the negative access will get value in the point which is relevant to the array. Yeah, that's right. That is accessing memory that it does not belong to the array, right? And I think that's what you want to say is irrelevant to the array. Yeah, it's outside this array. Then where is it? I think on this computer, I think it's probably the unallocated memory, right? Because the data array is on the stack, and stack is growing to the lower address from the higher address. So I think we will get location that is unallocated memory. So probably we will have segmentation fault. Okay, I cannot be sure. I need to do experiment. A hacker, I mean, people who hacked into other people's system, not the programming hacker, but the unethical hacker. They will use this kind of tricks very often. But when we write in macro program, we also use this kind of tricks, but we will never write code to access negative value outside my array. What we do is to like to use the old data, the offset array. That is why I, in the beginning, that we declare all data pointer like this. We first get a buffer, and I want legal access to my data. I do not want to access uninitialized or outside data. That's not what I want. I want correct answer. But I also want the ability to be able to use negative index. And why this is so meaningful to us is that, you see, this positive value access is done by compiler, right? So the calculation of the offset of memory address does not happen during compile, does not happen during runtime. It does not take any cycle to do plus and minus. And so is this negative value. So I do have other approach to achieve the same thing, but that will incur runtime overhead. That overhead can be tiny, but still overhead, right? But this does not give me overhead. During runtime, nothing happens when I access negative. It's just like accessing these memory address, like the positive index. So that's pretty nice, right? Remember that what we want is speed. We want fast code. Okay. All right. Next thing is floating point, what we call real number. We care so much about real number because integers are not real, right? I hope you have laughed because it's supposed to be a joke. Yeah. When I feel embarrassed, a little bit embarrassing myself, I will say that's supposed to be a joke. You should laugh. But remote teaching is so difficult that I cannot even see that you are following my instruction, which is sad. I hope we can go back to the classroom someday. Yeah. Floating point are not exact. It was not designed to be exact value. So we want floating point to be imprecise. But the precision of floating points can be controlled. The format of the standard floating point that we used on most of our computers right now is that the value is positive or negative of 1 plus the fraction, which is used 2 as the base, times 2 of the exponential p. Okay, but p is biased. Okay, so this is the list. We will use the bit to store the sign. So signness is no longer a problem for real number or floating point because the data type itself carries the sign. Integer does not carry the sign, right? We use the Boolean algebra, the Boolean sorry, not Boolean algebra, the 2's complement. To calculate and to represent the negative value. So the same bit pattern can be both positive and negative. And that's the problem we ran into when we are mixing the signness of the integer types. But floating point does not have this problem because there is no unsigned floating point. All floating points are signed, and there's a bit to store the sign. Okay, and there are 2 variants about the floating point format. These variants are used 2 as base, but there are also decimal based floating point. But usually we use this binary base. Okay, this formula is very important. Okay, later I will show the bit pattern, which is also important, but this one is much more important. You need to know the 3 components of the floating point. Then when you estimate or study the accuracy of your code, you know where to find this problem. In a numerical analysis course, well, people usually just skip the integer and start or the whole course with the floating point representation and tell you how to assess the accuracy and how to control this what we call round off error. Okay, but here we are not talking about numerical algorithms or numerical methods. Well, if you are interested in that, talk to me. I have a lot to share with you, just not in an organized course. But numerical analysis is fascinating too. Okay, so the course name of this is called numerical software development, but it's not less about numerical. It's more about software development. But all of the development activities are adjusted for numerical analysis. But we focus on the software development part, which I think is more suitable for computer science students. Okay, so that's calculating all the bit fields. So this is an example that I want to calculate this is decimal, 2.75. So I need to turn that into, okay, this is the easy way. I know that in computer architecture, you probably will learn different ways to do that, but this is the easy way. And it only deals with easy value. But this is straightforward, right? I write everything in the base of 2. So it's 2 plus a half and a half square. So it becomes 1 times 2 to the power of 1, 0 times 2 to the power of 0, 1 times power 2 to the power of -1, and 1 times 2 to the power of -2. So if I write it in the base of 2, it will be 10.11, right? Then if I offset the binary point, it will be 1.011 times 2 to the power of 1. Okay, so then we know fraction is 0.011. And P is 1. But remember, P will be biased. That we will show you in this page. So the bit pattern will be like this. Oh, the lowest 32 bits will be the fraction. So fraction takes the most part. The fraction is where we get the precision, or what limits our precision. Okay, so for anything that go after those fraction bits, we cannot represent precisely. And the exponent, there's a bit, and there's 1 bit for sign. It's from low to high by a bit. So this BIOS is the BIOS value of the exponent is 127, 0.11101. So our power of 1, I mean, this is the value of 0. So our exponent p value to be 1 will be having this bit pattern, 1, 3, 0, and 4, 0. Okay. Double precision is pretty much the same. It's just longer. So we have 52 bits of fraction, 11 bits for exponent, and still 1 bit for the sign. All right. Yeah. And before we exit this section, we have 2 slides left. The second lab is a handy facility in C++. There's limits. It provides a template called numerical limits. And you supply the type of value. It can be floating point, can be real number, can be integer. And there are those values defined, which is the lowest, the minimum, maximum, and the smallest deviation, the epsilon. I do not have the value printed. Okay, you should run the program yourself, or go find some online references. I think I have a link in the online notes. See those values. And I think I have those values printed in the online notes. Lowest and minima are the 2 very confusing things. And I have to be honest to you that I do not remember which is which. I think lowest is probably the smallest positive value for this type. So I think lowest probably is always positive, and minimum probably is negative. Yeah, but it is misleading, right? So when I need to use those macros, sorry, they are not macros. They are templates. I always go online and see what are them. And as far as I know, that all the reference I can read online are all correct. So this is some definition that's very difficult to get wrong as long as you have a good reference. And one thing to add is that this lowest, minimum, maximum are functions, but they are constant expression functions. So it does not incur any instructions during runtime. The value of the lowest or the maximum or epsilon will be pulled and inserted into your binary code during compile time. It does not generate instructions. Okay, so they work. In short, they work like macro. But the difference between these functions and macro is that they are C++ functions. So the return type can be understood by the compiler. Unlike macro does not have type. They are just string substitution, right? So compiler cannot do type computation against macro, but they can do type calculation against this. So if you are mixing, say, you are mixing the side value to on-site value, compiler can warn you. Okay, but compiler cannot warn you if you are using macro. All right, the last slide. Floating point support exception, and those exceptions happen in or are supported in the processor. So there are 4 types of error. The first type is that the math result has infinite or undefined results. So like I have a division by 0. Okay, the result will be infinite. That pretty much undefined. You cannot divide by 0. That's the limitation of mathematics. And inexact error means that that operation or calculation does not go exact. Okay. There are some error introduced in that operation, like square root. The result won't be exact because it is irrational. Even if we can represent a real number, doesn't mean we can represent irrational, right? Then domain error means that the argument is out of bound. It does not make sense to the operation, like arc cosine of 2. Okay, cosine cannot produce any value larger than 1 or smaller than -1. So what does that mean by supply arc cosine 2? It cannot get you any answer. So the result will be another number. Okay, it's different from infinite. It's not undefined. It's not infinite. It is something that cannot be computed, but in a different way than the pole error. Then range error means that the result can be too large to represent by the type, or be too small, too tiny, and due to loss of precision. So like if I get the maximum value and times to 2, I got an infinite, and it's an overflow, right? And if I want to divide my minimum value by 10, so minimum value actually is the smallest value, smallest positive value. So lowest probably is the negative value. Anyway, it's hard to remember. And, so this the smallest value close to 0. Then I still divide it by 10. Then I got an underflow, right? So it is outside the range of that type can represent. But so this is a question to you. You can think and probably provide an answer or an explanation or theory by yourself. And this is a matter of fact. When we see those floating point error, or when we have those floating point value, we actually do not raise an exception to stop the execution. No, we don't. Why? Why not? That those are real errors. Like divide by 0 is, of course, we'll get us something like unusable, right? This in the exact error is more or less tolerable. Well, we know that the square of 2 is irrational. I'm not expecting to be able to represent that in a finite digit. So this is tolerable. And but there are other errors. But usually we do not stop the programs from execution because of those floating point things, errors or exceptions. It's worth thinking. That will affect how you design your software. Okay. Yeah, there are reasons that we do not do this kind of runtime stopping. Okay, let's take a break. Let's come back about in 3 minutes. So we can take some water, or I can take some water. Okay, but feel free to ask me questions. All right, let's continue. The next topic I want to share with you. Okay, I assume you are all back. If you know somebody is still not ready, let me know. I can repeat myself. So, object-oriented programming is not such a new idea, and a lot of people are saying it is outdated and not useful. Don't trust them. It is not outdated. Well, it is outdated. And of course it's outdated. It's not so fancy anymore. But people still don't know how to use it in the right way. And it is not so easy to be to master, I would say. I do not claim that I know how to write good object-oriented program. myself. No, I still make a lot of mistakes. But it solves problems. Okay. There are a lot of fancy claims or paradigms popping up. But most of them are not well verified, and we do not know how well they go. In the industry, we also do a lot of attempts or experiments. I can share with you that we do attempt to do some more advanced or more, well, something that's supposed to be better, and we failed spectacularly. So I constantly go reading some analysis or things like how to write better code and how to make things more organized. But the problem is that when they are talking about the code development, they usually are talking about the code that's easy to maintain. Software engineering is more about making code easier to maintain, right? That's basically every engineering does. If you want to make something that can be sold to people, you need to reduce the cost. Okay, that's what we are paid for. As an engineer, we need to bring down the cost, not to make it more expensive, right? If I can do something using 2 people, 2 labor, 2 resources, then I should just use 2. If I can use 1, use 1. Not use 2, not 3. I need to bring down the cost so that when I am under competition, I can reduce my price and to give me a better position in the competition, right? There's nothing wrong about it. But of course, as a programmer, you always want, hey, why not give me more time or more people working on this project so that we can make it a better product, right? Well, that's our responsibility as well. But remember that we write program, almost all programs, well, not exactly all, but almost all programs are written to be sold in some form. Okay, somebody needs to collect money for the program you use, right? If you are doing painting, or like if you are a pastor serving in the Church of God, no, you do not need money, actually. You are doing art or you are doing religion. And the setting of art or religion are not supposed to be sellable, right? That the mid-aged Catholics made the mistake of selling the religion, selling the faith, and that's wrong. Right? That shouldn't have anything to do with money. You can use money. You can have some economic structure to make the church or the organization of any kind to go, right? That's okay. You are able to get the economy flow. That's okay. But your purpose cannot be selling things, selling religions or selling arts, right? But programs are supposed to be sold. Right? It's the reason that we use computers in the first place is that we want to calculate the trajectory of our ballistics so that we can kill people in a more efficient way, right? Okay, so everything starts from an evil intent. Or everything about programming, I should say. The very beginning is that, repeat, we want to get a good trajectory in a more efficient way so that we can kill people in a more efficient way. So it's double efficiency. Provide the machinery so that we can kill people. in a more efficient way. Okay, so it's really bothering, right? But it's good that we then turn to, hey, how are we going to use the same productivity machinery so that we can improve the life of people? And that is great. And by providing the life of people, you are improving the, well, we actually do that by improving your efficiency. And efficiency is lower cost and higher value, right? And most of the time that the value in the capitalist society that we have the measures of money to for our value. So that's part of the center of engineering. Again, I don't want you to get me wrong. Oh no, you can get me wrong, but I don't want you to get the things wrong. Efficiency is at the core of our profession. Okay, that's no doubt. And I am emphasizing money because a lot of people are thinking the things wrong, thinking that efficiency is just efficiency. No, you need to have something concrete in the measurement so that you can assess efficiency in the right way or in the useful way. Not say right. There are many ways that are right, but in an efficiency, in a useful way. And don't exclude money from your equation. Okay, your equation have a lot of operands. Money should be one of it. All right, so keep it in mind. And this is a very, very fundamental principles we call solid. That's basically for sounding cool. And I'll go there one by one. But this is just an overview. You need to practice. You need to write code, then you can understand what it does. The single responsibility principle is that each class, the unit is class, each class has one and only one responsibility. Okay, so this is there is one thing that is big. What is one responsibility? How to count responsibility? Okay, there are some artistic maneuver that you need to do. And the second is open-closed principle. It means open for extension. When you want to extend, it's like free. You are not constrained for extension. But when you want to modify the domain or the boundary of an application, or your modification has a boundary, you cannot go outside that boundary. You can modify outside the boundary. All you are doing from an application is enclosed somewhere. It's open-closed principle. This code called substitution. I do not really know who's this code, but anyway, this code substitution means that when you are referenced to a base class, you are in the hierarchy chain, inheritance hierarchy. When you reference to a base class, it can be replaced by a derived class just by replacing that declaration or something, and all the other code don't need to be changed. Okay. So basically means that you can replace the base class with a derived class. Okay, that's good, right? The fourth thing is the interface segregation. It's preferable to have more classes or more interfaces working together than a big, giant general interface. The word general, when you are feeling you are talking about something general, you do not really know what you're talking about most of the time. Okay, so observe yourself. When you are in a discussion with people, they say, I want to do something general and they can do A, B, and C. You probably don't really know A and B and C. Okay, then the fifth thing is dependency inversion. Means that you should abstract. Depend on the abstraction. The abstraction actually should be something solid in the code, some concrete in the code. Not really the conceptual abstraction. So depend on this abstraction layer rather than the implementation, which really define the operations. Okay, but they are both code. Okay, depending on abstraction doesn't mean that depend on something in your mind or on paper. It still means something in the code, but it does not define how it does. Okay. So if you have heard about these principles, I really love to know. Okay, you can Yeah, if you want, let me know that you are already aware of this. And you can also provide me some feedback. Say, maybe my interpretation is not exactly what you understood. Maybe I was wrong or have some misinterpretation. Let me know. Or maybe you agree with me and you want to let me know, that's good as well. Okay, you can use anyway. Okay, probably try not to use the E3 email because somehow that is not so dependable. Sometimes I miss that. Send me the email, send me the message. They're all good. Okay. It's important to do encapsulation when we do in outer program. It uses some of the principles we listed. But I'm not going to make those principles as doctrines that you have to follow them, then you are a good programmer of outer-oriented programming. Well, you probably will be, but I don't really care about whether or not you follow those principles. But the encapsulation is one thing. It's actually part of the principle of the open close principle. But that's more like a lot of combination, right? So my way of doing encapsulation is that I think the key is that to separate the interface from implementation detail, or have the distinction between abstraction and implementation. Then we can be open for extension and be closed for modification. But it doesn't really matter if you are coding yourself, like what we will do in this course. But there can be some difference. Hey, by the way, we have 32 people here. Okay, this is something about number. Oh, no, sorry, I was wrong. So we have 27. Okay, that's fine. Okay, I will try to count you, every one of you, for your term project. Okay, but I can only do that online. It is not because of the pandemic or the lockdown. It is because that I have a full-time job and it's very demanding. So even for my day job, I am not able to coach or walk with my colleagues in person. No, I couldn't do that. I won't be able to do that. We do everything online. Way before this COVID-19 things. So most of my meetings are online meetings. I haven't, well, I like to go to the office, but actually I work much more efficiently in my home office, which is here. What you are seeing is my personal aspect of my daily work. I have another direction actually turning that. I have another set of workstation that is for my day job. So I have been operating in this way for like 8 years, I think. Yeah. So I want to coach you in this way. This is one of the most efficient way that I know actually. So I believe eventually, if you want to be successful in your programming career, well, you will be like that anyway. So that's one aspect. The second aspect is that, well, while we do this online communication and discussions, we will use a lot of asynchronous tools like emails, like GitHub. They are very good productivity tools. And it's better for you to get used to that. Even for this, in the past semesters, I think I usually have like 7 or 15 people taking the course. So it's not a big deal for me to read through your things and make comment. And some of you have already posted the proposal online in GitHub, and you saw that I have responded to you. Sometimes I take some rest that I didn't respond instantaneously, but I am able to actually. I just don't want to push myself so hard. So sometimes you'll wait 1 or 2 days for me to respond. But you need to remember that you better get your ideas written out as soon as possible, so that because I manage my time, I choose the best time for me for all kinds of work, including my day job and my teaching. I have other activities. So I prioritize them and do them in the best hours. If you accumulated your work close to the deadline, sorry for my pronunciation, not deadline, deadlines, like in like 3 weeks, you may be in trouble because I might not be able to respond in time, and I still will grade your proposal, but you will not have the buffer for you to make adjustment, and that will impact your development hours as well. So that will have a chain reactions. Okay, and that's not very good. And so make sure that you don't try to write up a perfect passage. No, you can write up something that you are so unsatisfied with, and the next week you throw it into the trash can and start over. I'm fine with that. You should be fine with that too, because that's how software development should go. Especially for the numerical calculation we do. Okay. In some industry or application, like if you want to be a web programmer, some IT stuff, well, some of the work is finished by like 3 hours. Then you do not really need to write a proposal or a specification. No, if you can get it done by 3 hours, then you just get it done. Why plan for it? There's no point of plan for something that you can just spend an hour, in an afternoon in the cafeteria, get things done. They just get things done. Okay. But scientific software or numerical software is not like that. We need to think well about what we do, and make sure we know how to verify our results. And that usually incurs a lot of calculations that you can try to measure the timing your program, and realize when you get the results, how much time you use. I mean, the wrong time you use, and multiply that with the AWS price and see what is the cost of your computation, excluding everything from everything you code, all the hours you code, or the hourly rate you estimate for yourself from that cost. Only the computer cost, and you will be shocked that you are cheaper than computers. Okay, I think in most of the programming education that we've been taught that we do software engineering because that programmers' hours are more valuable than computers' hours. So we are more expensive than computers. Yes, you are more expensive than the MacBook Pro in front of you. Of course you are. But you are much less expensive than the giant servers sitting in the data center. They are more expensive than I am. So my hour is traded for their hours. Okay, we are very willing to spend programming hours so that we can shorten the runtime in the server farm. Okay, and you do not have easy access to server farms because they are very expensive. I do not have access to server farms. Sometimes I have to beg our IT to give me computer hours so that I can do some experiments because I am cheaper than the computers. So this is what we have. That's why we are taking courses, I mean, the development courses that is seemingly contradictory to the popular wisdom. There is a fancy term called supercomputing that is talking about what we do. All right, so that's encapsulation. I'm trying to use all the activities to prepare you for good collaboration and all those engineering stuff. But let's do this step by step. Next thing is in the language. For encapsulation, this access control will provide facilities. There are 3 kinds of access control in the class, C++ class. One is public, that, ouch. Sorry, I have flipped this public and private wrong. Let me do the fix right now. I'm so sorry. This should not happen. Why I mess it up? All right. All right, this is correct right now. So the private access is that I think in documentation or in standard, it's called access. So everything either outside or inside my class can access this kind of thing. It can be a member data, a datum, or a function, or say class method. There can be a private access that only the class itself, not if the derived class. Okay, only the class itself can access anything that's marked as private. And there's another class called access called the protected, that the class itself and the derived classes can all access it. Okay, so this is the access control. Help us to do encapsulation. And so we will have member data. In addition to functions in the class, we will have data. So algorithm around programming is to combine logic and data together to put them in an object, right? The object is having data and logic. Okay, not just function or logic, not just data, but they are combined. That's an object. That's why they say object-oriented is not intuitive, because it is not really model the real world. It's just combination of data and functions. So we will have data, and we should use some naming convention for the member data. Okay, it's almost a must-have. Well, I would say it's a must-have. If you do not have a naming convention for member data, it's almost impossible for you to read your code. You can still write, but it's very difficult to read your code. So difficult. So this is some 3 common conventions I've seen. One is to use the underscore, that if you are okay to have underscore in your entities, then you prefix m underscore, means this is member data. It is very universal that if you see some name have m underscore something, it's member data. And if you want to name your member data using camel case, you still prefix lowercase m. I think usually actually I saw this underscore much more often than this camel case. But even in the camel case, I think they prefix underscore m, not capital M. Capital M looks very strange. Okay. Another style, which is less often I see, is the underscore postfix, that to indicate that's member. Well, I personally very much like this m underscore data. It's almost impossible to be mistaken as something in local scope or a function. Yeah. And I also prefer this underscore thing. I know a lot of people does not like this underscore. However, the standard library actually use a lot of underscore. So writing this will make your style to be like standard library. So that's not a bad thing, right? Okay, and we have a term, I probably mentioned that before, that's plain old data. That means the C style struct. Okay. C++ support it as well. For plain old data classes, I mean, a class can be just like a good old plain data. And in that case, sometimes we do not have this prefix or postfix convention because you want to access a member just like it's the plain old data. So in the past, the convention does not have this anything because those data classes only contain data. They do not have functions. So why distinguish, right? So in that case, we do not we can omit this convention. But it's up to you. I would say it does not hurt, but it's also good to still have this convention in the POD classes. And the most important thing is that you do not use more than one style in your code base. Okay, and if even not so good, when you have a third party, you are using a different convention to the major third party code that you include. So if you are very sure that you will not use the significant third-party code, you can be original about your coding convention for the member data. But if you do, try to use a convention that is not incompatible to your third parties. Okay. And a little bit explanation of the syntax for the class. We have a lot of contents to go through. Okay, so let me do it quickly. So we can use class or struct to make classes. And the difference is that when you use class, that the default scope access control is private. So this thing does not have access specified. It will be by default private. But when you are using struct, and this thing is public. Okay. And the fun fact, do you know what is the smallest size of a C++ struct or class can be? If you know, you can type in the chat. Repeat the question. What is the smallest size a C++ class or struct? They are the same thing, okay? What is smallest size a struct or a class can be? Smallest, okay, not the largest. Largest is basically there's a limitation by your address space, right? What is the smallest size? It cannot be negative, right? Nothing can be negative in the computer memory consumption. Even for compressed type, it's just reducing the type, it's not negative. Right? So what is the smallest size of a class? Okay, in the class that we will have member data, we will have member functions. So the accessors are a special purpose, but it's a very common, it's something we always have. And their purpose is to access the member data. Because in the point class, we have our member data protected, right? They are not available outside my class. So how am I going to access my data? Okay, here we do have contradictory here. For good encapsulation, outside the class, consumers are not supposed to know what data I have, right? If they know what data I have, that I actually leak through my encapsulation, they know something inside myself. And how am I going to change my interior after they know myself, right? So in terms of encapsulation, accessors are a bad thing, okay? but we always have it. Because when we are dealing with dynamic calculations, that we are dealing with a lot of data. And most of the time in the beginning, we do not know what is the best way to access the data or use the data. We do not know. And then that's almost impossible for us to find out what is the right algorithm to process the data. We know that there's a right algorithm after we write the code and run the experiments, see the results, and in my case, send it to the ship to the customer, and they pay the money. That will be like a year or two later. And I still need to maintain the code. And first of all, I need to make it run. Then I need to maintain the code without knowing it is working. All right. It's even so when I was still doing research that, yeah, even after I published the paper for my results, I know that what I wrote in the paper is correct. But how do I know it is valuable? It is just a paper. It let us know something new. But I am an engineering scientist. How do I know the method or strategy I proposed in the paper is really applicable in industry? I do not know. I can only know maybe after 5-10 years, somebody grabbed the paper and applied it into a product. And that person or that group of people probably won't be me. And I still need to write the code, right? And probably need to maintain the package to make it useful so that there's a better chance for somebody to grab it and to apply it in the real product. So I need the accesses. Okay, I cannot make perfection of the perfect after-written concepts. So I need to provide accesses. Okay, so yeah, it breaks abstraction or encapsulation, but we can write very, very little code to access the data and to come up with some numerical algorithms that we need to do. There are generally two styles of accesses. One is the getter and setter. The second is what we call single method name. That will lead to reference that we are going to talk about in the next page. The first style is simple. You probably are using that already. First, we have the getter, which is usually the const function, which means it does not change the class, okay, and just return the value. The setter will provide an argument and set the interior to the argument. Sorry, to set the argument to the interior. I'm sorry about that. And it cannot be const anymore because it will modify the class itself, right? So code is like that. I have a point, an instance of the point class, and set X and set Y and print it. It's set. And when I print it, I need to get X and get Y. Okay, so this is an anti-pattern to a lot of people. Say, hey, why are you using accesses to print? You should overload this output stream and so that you can, but it doesn't really matter for us. The second style is a single method, and then it uses references. But again, the getter part is still a constant thing. But here I am doing something controversial too. I am returning the member data, but I'm returning a constant reference to the member data. So actually what I'm returning, I am returning by reference, of which I'm going to explain a little bit more. But remember that I'm returning reference, okay? And this is will be funny, right? Because the floating point, the single precision point takes 4 bytes, right? It's single precision. It's not double, it's single precision, 4 bytes. And later we'll say that this reference actually take 8 bytes, okay? Because it's of the size of the pointer. So most of the computers that you're using right now, the pointer size is 8 bytes. So by returning by reference actually takes more memory than returning by value. And that will have performance implication later. However, I'm writing this not so good code to show you it is possible. And sometimes compiler can actually optimize it, depending on the consuming code. And it will work. What's more interesting is the setter part, that you are returning a reference to your member data. Because it's not constant, so you can return a non-constant reference. And you can write code like this. This is calling the setter. You are assigning 12 to your interior. Compiler is able to generate code that does not call this function at all. It is also possible to generate code that does not call the getter, actually just pulling out this interior, okay, directly, just like the POD. So this is the getter part. So we rely on function overload because these two functions have the same name, but their constantness is different, so that there are two different functions. And because of compiler optimization, you won't even see the symbol in the generated binary. Okay. If you are interested, I can tell you how to inspect the binary. It's very interesting, but that will be a lot of learning. I will recommend you to take time to learn it piece by piece. Whenever you have a question, you can come to me. And you can come to me in the future because you know me. You don't need to ask me more detail in this semester. Okay. Try to make sure that all your classes are doing well. That's very important for your success. Okay, so we mentioned about reference. It enables aliasing to a variable, work like a pointer. But what it is like, no, sorry, what is different from a pointer is that you cannot construct a reference without initialize it to a variable. You have to initialize it to point to something. You cannot point it to null. Well, there are ways for you to hack into the compiler. I mean, write the code that deceit the compiler, saying that you are taking a reference to null. Of course, that's a bad thing, right? You shouldn't do that. So this is the explanation that I have a variable, the value is 10. I have a pointer which is not initialized, right? It is dangerous. So compiler actually will warn you if you turn on the relevant warning. Then you can take the address of the variable, assign it to the pointer, and set the value of the pointer, the value of the variable the pointer points to. Then you can print V again, you see it is changed, right? Then you see how the reference is working. You need to declare a reference, but when you declare it, you need to initialize it to V. And you use your reference just like the original variable. Then you can do whatever you do to the original variable. And you can try if you you declare a wrong reference that is not initialized. Compiler won't allow you to do that. Okay. And this is the verification of the fact that all those variable and pointers are taking the same address. Okay. I have another example which wasn't shown here. That is the CRV, not the car, but the constant reference to variable. Okay. So references is a very important facility in C++. And I spelled wrong. Sorry. Let me fix it. Not sure why. Okay. these constructors and destructors are another important concept of C++ that before construction of class, we do not have anything real during runtime to operate with. We won't have data, right? We need to instantiate the class so that we have data inside it. Yeah. So those objects, what we call an instance in C++. The objects are more like the general concept of object-oriented programming. But in C++, we interchangeably use the word object and an instance. And the instance has two meanings. In the future, we will introduce. There can be as many constructors as we want, and including overload. They are overloaded anyway. There are special constructors that compilers provide or compiler write for you, and you do not need to write if you don't want to. Okay. So let me introduce them one by one. The first thing that compiler can provide you is the default constructor. Compiler may not be able to provide you in some occasions, but over time it can. That's the most important, most fundamental constructor for a class. That means if you are constructing the class without any argument, it will go with this default constructor. There will be some cases that you cannot provide argument to the constructor, which is like a construction in an SDL container. And the signature will be like this. Okay, this is default constructor. So if your class is not too special, compiler will generate the default constructor for you, and most of the time. Then are the copy and move constructor. We will not go into move semantics right now, but there are these two. Copy constructor will take a reference to and construct from the input argument. We usually use a const reference because when you are copying an object, usually you do not want to change your source, right? If you change your source, then what's the point of the copy? That becomes very strange. Okay, so there are very, very rare scenarios that you actually want to take a writable reference. But I would say it never happened to me. So you can assume that you always want, in practical, you always want the const reference to input your copy constructor. But the move constructor will have a different signature. It will take a writable reference and the R value reference. Okay, not an L value reference, but this is a little bit detailed. Okay. So we know the distinction of these two copy and move constructor. So the distinction actually lies on the detail I mentioned, that the copy constructor is actually taking usually const L value reference. So it is an alias to an existing object, and we do not change it. The R value reference will extend the lifecycle to a temporary object. And when we have something like this, an R value, it's not limited to temporary object, actually. That's why it's called R value rather than temporary value. There are cases that the R value is not a temporary object, but usually it is. Okay. So we have an alias to this usually temporary object, and we can do something to it because it's mostly temporary, right? It's supposed to be going away after I'm done with that. So I can do whatever I want. So it's almost always writable. Okay, we will write it to change the internal state. And there are two companions to this two constructors. So they are okay. They are copy and move assignment operators. Okay, so I do not cover them, but in the next page And you can also think about the question, do you know how to write? Have you written move constructor and the move assignment operators? Okay. That question will help you to assess how much you know about C++ and its practicality. So is the rule of 5. Okay. If you write C++ and you do not know rule of 5, you better don't say that you know C++ because you don't. Okay, when you are writing, because constructors and destructors are so essential to the language. Remember that in the beginning of introduction of object-oriented programming, C++, we say each class has one and only one responsibility, right? And how are you going to create an instance of a class? You need constructors. And when you need constructors, you do need a destructors, right? Unless there is a singleton in the memory that living until the death of your process, then you need to destruct your classes, your instance at some point. Okay, so class is there the center of OO. Then constructors is the necessary bit for the class that you want to use. And that will introduce destructors, which you must call after the life cycle of your object. So we need to be very careful about, okay, let's not say very careful. Let's say you need to be very familiar with constructors and destructors. And rule of 5 is talking about when you need all those constructors and associated constructs. Okay, so it is saying that if any of the following, including destructor, copy constructor, move constructor, and copy assignment operator, and move assignment operator, if you need to customize any of them, all of them should be explicit. Okay, this is with this they call programmers call it a rule, but actually this is like a generalization of experience. It is not saying that if you do not follow the rule, you are writing a bad program. It's just like you are likely to write a bad program if you do not know what you do. Okay, so a little bit of extension. Now there is a default keyword introduced in C++ 11. Oh, all the C++ we are talking about here is about C++ 11 and beyond. We do not talk about C++ before C++ 11 standard. Okay, so this is just assume that you must use C++ 11, and there is this default keyword. It has a direct impact to how we follow the rule of 5. That we can use this keyword to say, hey, I know that compiler, you will generate some default implementation for my constructors and destructors. I know it. But I still want to write in the code, say, hey, compiler, do that. I know you'll do that, but I want to tell you, please do that. So this is to say, hey, my default constructor uses the default implementation. The default implementation is compiler provides you. It doesn't mean the default constructor is a default implementation of the default constructor. Okay. And so is to the copy and move constructors and copy and move assignment operator and destructors. Okay. Not all functions can have default. Only those who are will be generated by the compiler by default. Okay. Why? Because sometimes compiler does not generate the default constructors. And the rule it's clear, but I would say it's hard to remember. I myself do not remember. So my habit is that, all right, it's just 6 lines of code. I do not remember when the compiler will generate default or it does not. So let me just spit it out. So everyone reading the code will know, oh yeah, it will create the default constructor because I said so. And if compiler cannot, compilation will fail, right? So I will know immediately. There are cases that when you are very much understanding that there will be default or not, you do not need to write it. And even I myself, when I am in a code base that have the convention very clearly followed, I do not need these things to remind myself or my fellow colleagues. But it is good to know if you are still unfamiliar with these things or you are in a code base that does not have a very clear guideline for whether or not omit those default lines. This is a good practice. There is also the delete keyword, which is much more useful. It tells the compiler that do not generate the implicit indentation. Do not. So this will change the compiler behavior. That in some scenarios, when you write the code, it will generate the default constructor or destructor, right? But after we say delete it, like here, I am deleting the default constructor. Do not generate the default constructor. Before introduction of this keyword, there is only one way to prevent the default constructor being generated. It is to use the linker. That is, you declare this default constructor, but you do not provide an implementation. So the linker will fail. Okay, that effectively is the same thing, but you do not get the result in compilation phase. Oh, there probably is another trick to do that without the delete. I couldn't remember what's that. That's probably another trick before C++11. But we don't need to remember that anymore, because the standard right now tell you can delete any of the default. So like here, I delete all the default things and ask my users to only use my custom constructor to construct my line, which makes sense, right? Because, well, in this specific example, it is I am telling my users, you cannot create the line without initialization in my way. I do not need to write any comment. I only need to have the 6th line of code. And users will know that, oh, this is a very limiting class. I need to have 2 points in this order so that I can construct line. That's it. Okay. And I still want the default destructor. Okay, so I write it here. All right. Oops, I probably need to be faster. Let's take a break for 1 minute. Okay, I will be back in 1 or 2 minutes. I will be back no later than 9:26. Okay, pose questions if you have. All right, I'm back. Okay. Oh, so Chris posed a thing. Wow, this is a great picture. Where do you find it? That's good. Yeah. Okay, so to be honest to me, can you remember this picture? Do you think you want or you are able to memorize this? Well, let's say do you want me to put this thing in your midterm? Yes or no? Oh, Jonathan, you want it? Oh, you say no, then laugh.
No,
Okay,
no,
so
no, no, probably not.
Probably not. Okay, I like you. Chris, why? You should feel excited about that. No. Oh, sorry, I was just joking. Of course, that no, never try to memorize this kind of thing. Unless you are going to take a job to make C++ compilers. Okay. I will not trust a compiler made by somebody who cannot memorize that. Okay. If you work on a compiler, of course you need to memorize this. Otherwise, how can I believe that you are making the rest of the compiler in the correct way? Right. But because most of us won't be working on a compiler, so it's okay. Don't remember that. But this is good. I need to keep this somewhere, bookmark it, so that I can steal this nice picture. Thank you very much, Chris. And do more like this for me. Wow, you will help a lot of people in the future taking this course. But I will try to help you in this course. And if you like what you learn, I will try to help you do as much as I can to help your success. And another question: how do you? Am I going too slow today for the C++, or do you think? Well, three options: slow, okay, or too fast. Am I slow, okay, or fast? How do you think? I know you will have different opinions. That's perfectly fine. Please give me some feedback. Okay. I do know that the organization of the materials can bore some people. Some of you already know a lot of this. I'm sorry about that, but there are also other people who are not so familiar with these kind of things. And still, those are essential information for programming for our applications. Okay. And in the future, I will still have a lot of things like this, which can bore you. I'm sorry. But while I am boring you, I'm still telling you those boresome stuff is important for our programming, and we can in any time to diverge to some discussions that uses the information, which can be more useful. Okay. So let me know if you want to know something other than the materials. And after all the materials are in my course note. I know it's not perfectly written, so probably not very easy to read. But this there, right? So if you have questions, you can also ask me. Okay. Yeah. Oh, Chris gave me a very informative comment. Let me speak out loud. There are some, maybe I think C++ cool stuff in the senior member in his lab or her lab. Yeah, that is a very important piece of information that you usually learn these kind of things. doing practice rather than in class. It's very difficult to teach this in the class. But that's my responsibility, right? I as an instructor, that I should make sure that it's conveyed to you, and you can easily digest the materials that I provide, right? It's not your problem, it's my problem. But the reality is that always so difficult to convey and transfer the knowledge on slides, on notes. You have to type it in code. That's why we need to do the project. Okay, then let's go with STL. It is important for us to use STL. We do need to process a big amount of data, so put them somewhere in the STL. And so it's the second bullet. And the template library is what we want for containing the data, because it tells us, it uses template. It generates the container during compilation. So, and save a lot of cycles for determining the types during runtime. That's why we need a compile language like C++. And that's why later you'll see it's very convoluted to use template. Why do we use a convoluted way to write code? Because it is fast. That's the only reason. Otherwise, we really don't, well, we really want to write Python. Python is much easier, right? Okay, so we use STL. There will be something I'm going to make a quick introduction to you. Vectors, which are sequential containers, array and list, and associated container like map and set, and unordered map and set. Okay, so ask yourself what containers you have written in code, and you are welcome to tell me about that. And the more I know you, the more I can help you. And what do you think a professional programmer must be familiar with, and why do you think so? Okay, based on your experience, it is not okay, there are correct answers to these questions, but it varies from one to the other, right? It depends on what kind of applications or systems you are developing. And there can be different answers. But that is the general direction about how to answer this. So try to answer yourself. Try to let me know what you think. Okay. If you do not provide it in the chat and still want to respond me, write me an email. Or you can write, create an issue for discussion in the in our GitHub, the homework one. Okay. Start with vector. It is a dynamically allocated contiguous buffer. Okay, and fun fact is that it is almost always implemented using string pointers. Okay, and that explains why you create a vector of integer, a double, and the nested vector of double, and the size of the vector is always 24, which is 3 pointers. It's interesting, right? And so you are encouraged. Vector is a very, very simple container, so you are encouraged to read the implementation in your compiler. When we say in compiler, it actually means the standard library provided with the compiler. Okay, not really the compilation code, but also include the library here. We call it dynamic allocated because it will create a buffer by asking for memory from the standard library or operating system. So the buffer is created like this, a data buffer, and inside, excuse me, in the standard, there is actually a member function called data that will return you the pointer to this buffer. So it has a pointer to the beginning, pointer to the end of the size, then the pointer to the end of the buffer. The end of size may be different from the end of buffer. Okay? Yeah, you can read more in the standard implementation and some online documentation. What we like with vector is that it provides fast index access. So you declare something that can be empty, and you can incrementally add elements into it. You can also populate by using the iterator, C++ iterator. Then you can index that using index, the integer value. Okay, we never index using floating point. It's possible for you to create a container for using floating point as index, but that's foolish. Don't do that. You are shooting yourself in the foot. There is a helper at providing the bound check. So if it is out of the range, it will raise an exception. But there's only a non-bound check accessor, which is dangerous. You can go out of range. But do not think it is bad only because it is dangerous. Oftentimes we use this non-checking this index accessor because the type check, the bound check incurs significant runtime overhead, even for a simple container like vector. Okay, and we can get the internal buffer, but be careful about that, because when you are enlarge your vector, like by populating more elements or doing resizing, okay, you will change the address of your internal buffer. So you need to know very well what your vector does, your vector implementation does, before you use the internal buffer. Sometimes you can, sometimes you cannot. Okay. But yeah, sometimes you can. So you still need to be aware of this interface. That's vector. And we have array. Standard array is a sequential container that uses static memory. It does not allocate dynamic memory. So the number of elements in this template, in this class template, actually is part of the type. So this integer array of 3 elements and integer of 10 elements are 2 different classes in terms of compiler. And their behavior will be like the plain old data. And the compilers knows a lot in the standard array than in the standard vector. Like in the standard vector, compiler does not know how much or how many elements the vector will have, right? But because the number of elements is already included in the type information of this class template, compilers can actually do the range check at any time. Okay, so the index access, the index access still have the bound check, non-bound check version and bound check version. Okay, and this kind of operations, and including the range 4, this is some new syntax introduced in the C++11. Basically, get each of the element inside this range check element access and this range base 4 are something that our POD cannot do. Okay. This can only be done. These 2 things can only be done with our the array interface, standard array interface. Then this is the linked list. This in C++, I think the standard mandate that the list need to be implemented as doubly linked list. It can traverse forward and backward. There is another type, is I think it's called forward list. That is a singly linked list. Okay. Linked list has a special trait that when you are transferring the elements from one list to the other of the same element type, of course, then the element the transport of the element do not incur any allocation of memory. Because it's linked list, so it's just a change of point between the two lists. Then we have the associative containers. We have map and unordered map. The major difference, let's say the map is a tree and unordered map is hash table. Pretty much that is. The time complexity have, they have different time complexity. But the order actually makes a difference. The map is a key value associative container, right? There is a no key version that is a set, which also uses the tree, usually reflect tree. And the unordered set is also use the hash table, but it does not have a key. Okay, that's the associated thing. Okay. So that's STL. Trying to get yourself familiar with this basic template library and container. Another reason, in addition to reuse the code, high quality code provided by the compiler, another reason is that by following the STL interface, you can use other implementation of STL for your code. You can almost upgrade your performance or runtime behavior by changing the STL implementation. You almost don't need to write any code. Just change STL implementation. You can do that by configuration or maybe create an abstract layer in your own library. That is very useful because containers are such an essential thing in almost all programs. By following the specification, the standard will give you a tremendous power of using other people's code. It is worth your time. Okay, then we have 1 and 2 topics. Yeah. One is polymorphism, but I would like to skip that or change the order. I assume that you all know about polymorphism, but I can skip it because we do not like to write polymorphic code in numerical software. Why? Because to support this runtime check, okay, there are a lot of runtime checks. Let me see. Okay, this is a diagram that we have different classes that inherit from the base class line, and we need to be able to determine the type during runtime when the code is executed on CPU. So we need to spend some cycles to determine the type, right? Because that's the behavior we are asking for. We need to tell the type during runtime. And it takes cycles. And we do not want to take cycles. So the best thing we are hopeful for calculation is that the calculation is already done during compilation time. So that I actually during runtime I do not need to calculate. That should give me the fastest runtime, right? Just like the thing that we did, a little bit like the thing I introduced last time. I say, when you want the buffer of 0, calloc can run faster than malloc plus initialization, right? Because operating system, when that allocate the new pages for you, should already initialize the buffer with 0. So calloc should give you a faster speed. And malloc does not have that implication. So you still need to initialize. Do the initialize again when operating system already do that for you. And here is similar, but here is a compiler. If I can offset the computation from runtime to compile time, that's great for my performance, and I want it. And polymorphism requires me to do some calculation during runtime. So I do not want to do that unless I have to. Okay, so whenever I have a choice, I do not use polymorphism. But I still want an inheritance hierarchy, right? So let me introduce some people call it the static polymorphic. Of course, it's not polymorphic. But we use the technique we call the curiously recursive template pattern. We use template to do something that similarly like polymorphism, but it's not. But it seems like polymorphic, so that's pretty good. So we make a class hierarchy behave similar to polymorphism without any runtime check. And that's exactly the reason it's not polymorphic. Because polymorphism requires runtime check. Okay. The advantage is no runtime overhead, and it does not have memory overhead that polymorphism need to incur. Because when I instantiate an object, which is polymorphic, and it needs some runtime information of that type, right? Because compilation and runtime execution happen in different time. You cannot, during runtime, you cannot go back to check your compilation information, which doesn't, well, even if there is, in the runtime, it can change, right? So it still needs some bytes to store the information for the instance. So there are overheads both in runtime and memory, and CRTP does not have both of any of them. So the syntax is that I have a parent class that with the template argument for my derived class, my child class, that class. And my child class will inherit from my parent class, but supply myself, the child class, as the template argument to my parent class, so that my parent class will know what is the derived class. But remember, well, it's not exactly parent, it's not exactly a class. It is a class template. Okay. You might heard people say template class, which is a wrong term, because there is no such thing as a template class. A class is a class. A template is a template. A class can be instantiated to an instance, an object. But the template can also be instantiated. But the template is instantiated into a class, not an object. Okay, the standard really use the term instantiate refer to both things. A class can be instantiated into an object, and a template can be instantiated into a class. That's why parent is a class template rather than a template class. A template can be instantiated as a template. Sorry, it's complicated. A template can be instantiated into a class. Then the class can be instantiated as an object. Okay. If you haven't written code like this, you probably don't fully understand what it incurs, and that's fine. Just keep in mind, the term class template is correct. Template class is incorrect. But when you write template class, I know what you're talking about. Okay, so it's not a bigger, but that difference actually makes you better understand why and how we use the template. They give you a better picture. Okay, so the syntax is like this. In the code that in our base, we have a distance function for the point. And if you try to call this function, it will fail. Actually, compiler will check because the check does not happen during runtime. Compiler will check, wow, this function is gonna be called by some consumer. then this static assertion will take place. Oh, okay. So it will happen. Compiler will check for you. The compiler will check, oh, this function become active in some place. So I cannot let it go. I must say raise the exception and check the checking criteria is that my base class distance is different from the derived class distance. I need the same address to be true. Okay, so this will fail if this function can be executed. Right? Then I return something in my derived class. And in my derived class, actually I overwrite my parent class function, right? So actually this thing will never be executed. And so is that. So this in the base class, this check is to guarantee that my similarly virtual function will never be executed. I can never execute this thing because I have to override this. So this check and this invalid code is to make sure that I get overwritten. Well, you can pretty much do the same thing by omitting the definition, but then it is a linker to make sure that there is no such function, right? Effectively, they are the same. So this is the evolution. So I have explained it to you. So when we run the code we just wrote, then the derived class in the CRTP pattern is really a normal class. It's nothing about the polymorphic. And we can print the size, and you see there's no additional bytes in them. And we can get the behavior we want. And this is the thing that we want. We only have the 2 floating points for the point coordinate, and there are only 8 bytes of them. Okay, so this pattern is usually useful when we are dealing with something like we want similarly like polymorphic, but we want it for a small class, very tiny class. We want to preserve the memory behavior and the runtime behavior. So usually we do not have a lot of derived class using CRTP because that is actually the code is difficult to write. If you have, in my experience, you have like 10 or 20 derived class, well, you probably should just use polymorphic to share and to have the runtime determination of the type of information. But keep in mind that those classes won't run very fast. There is some overhead incurred. And modern CPUs already accommodated that kind of runtime behavior. There are a lot of circuits in the chip trying to make those determination and runtime check run very fast. So you probably won't feel a thing between a static implementation and the dynamic implementation. However, advanced hardware like GPU, like other things that's still in the laboratories, do not have those advanced execution feature like we have in the Intel or ARM chips. So, and you know, numerical calculation is all about speed, right? So who are going to use those advanced hardware? We. We are going to use them. And we are writing code to use those advanced hardware, right? Then if you depend yourself on the polymorphism, you are likely to go in the dead end, say, oh, sorry, my code runs pretty slow on GPU. I need to rewrite it. My code probably will run very slow on FPGA. I need to rewrite it because I use some behavior that is too advanced to the hardware. And the hardware advancement is very fast. And I still remember that during the the transition of the 20th century. That was a paradigm shift in supercomputing. In the past, people are all using the mainframe, like a Cray machine, HP machine. And they use what we call the vector technology. We will introduce later on, but the last thing is already in your Intel and ARM chip right now. Doing supercomputing, they are pretty good machines, run very fast. But around late 1990s and early 21st centuries, people realized that those commodity desktop like PC runs very fast. The Intel is doing a great job making processor chips. Why not just using they call off-the-shelf hardware to do the supercomputing? Yeah, the single chip does not run very fast, but what about 100 or thousands? Right now, it is a common knowledge to you that when you want to run a big job, you can go Amazon or somewhere to allocate, say, 10 machines or 20 machines, right? That is the common sense right now, but that wasn't so at the beginning of the century, 20 years ago. So I experienced that paradigm shift that, oh, yeah, people are still start to write district memory parallel code for the supercomputing. And right now, almost all code is like that. And that kind of thing happened time by time. And right now, you will see in like maybe 2 or 3 years, Intel may not be dominating the server arena or the supercomputer arena. You already see that a lot of supercomputers are using GPU. People are writing GPU code, but GPU code is so difficult to write and maintain. So unless you have a very rich daddy, then you won't do that. And even you do that, it's a hard time to maintain the code. And there are even more hardware being invented. By hardware, I mean chips. You know, we are living on the island of TSMC, right? And they are making very interesting chips for everyone. As long as you have a good idea, they provide the facility for you to manufacture that, and they are the best manufacturer. It's not Intel doing the best manufacturing anymore. It was like 2 years ago. And right now, everybody is saying that TSMC is the best manufacturer. So there are a lot of innovation happens. You will see more and more advanced chips. What are you gonna do to use them? First, C++, because it can easily go and they let you go assembly. So and the third thing is that you can write very low-level construct using this. This is a pretty high-level language in concept to operate your hardware. But you need to have the principles in mind so that the code you're writing does not depending on some mature hardware facilities like the branch prediction and the virtual function table optimization in the chip, because the advanced chip does not have it. All right, so that's about it. Any questions? I should have left some time for you to ask questions. Yeah, but we'll get better down the road. All right. And if you do not have specific questions for me, and you do me a favor, maybe send me emails about what you think I can do to help you to ask questions. Okay, that's very important for yourself, so that well, but I cannot go have a one-on-one talk to each of you, right? So you can take initiative. Tell me what you want me to do to help you to know how to engage and start the discussions. Okay? I assume you are happy about that. So that's it. I will post the homework online, and let me know if you need anything else from me. Thank you very much. I will stay for maybe 1 or 2 minutes, but you are dismissed. Hope you have a good rest of the day.